When you hear the term machine learning, it's easy to let your mind wander to sci-fi movies, right? Some far-off futuristic thing. But here's the thing, it's not the future. It's right now. It's already shaping our world in ways you probably don't even think about. So let's pull back the curtain and really dig into what's going on here.
Okay, so think about this for a sec. What on earth do these three things have in common? The movie you just binged, that fraud alert text from your bank, and a car that can literally drive itself. I mean, they seem totally random, right? But believe it or not, they're all powered by the exact same engine.
Okay, first up, something you probably use every single day. You know that weirdly accurate feeling when Netflix or YouTube just knows the perfect video to show you next? Yeah, that's not magic, and it's definitely not a coincidence.
And then we have something a little more serious. Ever get that text from your bank, the one asking, "Hey, did you just spend $50 on a rubber chickens in another state?" Well, that's a system working 24/7 in real time just to keep your money safe.
And then, of course, the big one, self-driving cars. These are vehicles that can literally see, process, and navigate the world all on their own. And that common thread, that powerful engine connecting all of this, yep, it's machine learning.
All right, so this all begs the big question, right? What exactly is machine learning? And you know what? At its core, it's actually a pretty simple idea. It's really just about teaching computers to learn from experience, kind of like how we humans do it.
The whole idea here is a total game changer, a huge shift in how we think about programming. See, instead of a person sitting there and writing thousands of lines of super specific, rigid rules, we just give the computer a mountain of data and tell it, hey, you figure out the patterns. Think about it like this. You show a toddler a bunch of pictures of dogs, all different kinds. You don't give them a textbook definition, right? After a while, they just get it. They know what a dog looks like. Well, that's the basic idea behind machine learning.
And this is, no joke, a revolutionary change. The old way of doing things, traditional programming, was all about explicit rules written by a human. If this happens, then do that. Super straightforward. But with machine learning, the instruction is totally different. It's more like, here's a ton of data, go find the rules yourself. And this simple switch is what allows these systems to adapt, to evolve, and to tackle problems that are just way too complicated for a human to sit down and program by hand.
Okay, so how does a machine actually learn? Turns out there isn't just one single way. We can basically break it down into three main teaching styles, if you will: supervised, unsupervised, and reinforcement learning.
All right, let's kick things off with the most common one, which is called supervised learning. Honestly, the easiest way to think about this is like you're studying for a test, but you have the answer key. You give the machine a bunch of questions, but you also give it all the right answers so it can learn.
The reason this works is because the data we give it is all labeled. What does that mean? Well, for every single piece of data, we tell the machine what the correct answer is. We show it an email and say, this one is spam. We show it another and say, this one is not spam. We give it details about a house and we tell it exactly what it sold for. Over time, the model starts to see the patterns connecting the inputs to those correct outputs. And once it learns those patterns, it can start making really accurate predictions all on its own.
Okay, next up we have unsupervised learning, and this time we're taking away that answer key. We just hand the machine a giant messy pile of unlabeled data and pretty much just say, go nuts, find something interesting in there.
So with this method, the machine is on its own. It has to find all the hidden patterns and structures by itself. And this is actually perfect for certain jobs. Like imagine you want to automatically group thousands of news articles by topic. Or if a company wants to find out if their customers fall into natural groups based on buying habits without even knowing what those groups might be ahead of time.
And last but not least, we've got reinforcement learning. And this one is all about trial and error. This is probably the closest to how you or I or even an animal learns. You try something, and if it works out, you get a reward. If it doesn't, you get a penalty. And you use that feedback to do better next time.
A classic example is an AI learning to play a video game. It gets points, that's the reward, for a good move. It loses points, the penalty, for a bad one. And after playing millions and millions of games, it just naturally figures out the best possible strategy to win. This is the same principle that lets a robot learn how to walk without face planting. And it's exactly how AI like AlphaGo got so good it could beat the best human players in the world.
Okay, so we've covered what ML is and the three big ways it learns. But how do we go from just an idea to an actual working application? Well, it turns out there's a pretty standard blueprint, a 6-step process that's really fascinating when you break it down.
So this 6-step process is pretty much the core of any machine learning project. First, you got to collect your data. And usually, the more the better. But here's a little industry secret. Step 2, preparing the data, is often the hardest part. Real-world data is, well, it's a mess. It's full of errors and noise. Data scientists can actually spend up to 80% of their time just cleaning it all up. After that, you choose the right model, you train it on your nice, clean data, you test it to see how well it works, and then finally, you deploy it. You set it loose in a real-world application where it can start doing its job.
So we've talked about the how. Let's zoom back out and talk about the why. Why should you care about any of this? Because honestly, the impact of this technology is already massive. It's not coming, it's here. And it is absolutely everywhere.
Let's take entertainment and shopping. In that world, ML is the engine that drives personalization. It's doing more than just recommending your next binge watch on Netflix. It's also helping stores predict what you're going to buy next, so they can make sure that thing you want is actually in stock when you go to look for it.
Then you have finance and cybersecurity, where its role is, frankly, critical. These machine learning models are basically our digital bodyguards. They're scanning billions of transactions, constantly, in real time, looking for the tiniest signs of fraud or a cyber attack, trying to stop them before they cause any real damage. And it's all happening silently in the background 24/7.
And this is where it gets really powerful. ML is completely revolutionizing fields like healthcare and transportation. We're talking about systems that help doctors spot diseases earlier in medical scans, that can recommend treatment plans tailored to your specific biology. And yeah, it's the brain inside a self-driving car that lets it see and navigate our chaotic roads.
All of this really brings us to a pretty powerful point. Machine learning isn't just another piece of tech, another tool in the toolbox. No, this is a fundamental shift, a whole new way of solving problems. It's a genuine revolution that lets machines learn, adapt, and maybe even help us solve some of the world's biggest challenges.
So I'll leave you with this one final thought to chew on. We are actively teaching machines to find patterns in everything we do, in our data, in our behavior, even in our own biology. So as these machines get better and better at understanding our world, the really interesting question becomes, what are they going to teach us about ourselves?